Try this question so we can check if you understand the difference between isomeric structures and resonance structures. Okay, so first let's see which structures are resonance structures. Well, let's try resonance structures first. Oops, sorry. Resonance structures first. Notice that this has all of these have sulfur, carbon, and oxygen. Okay, so they could be resonance or isomeric structures. Notice that structure 1, sulfur is in the middle, but in structure 2, carbon is in the middle. So these two can't be resonance. Not okay. If anything, they could be isomeric, but let's not we'll address that later. So same thing with this. So these are not resonance structures. So here, structure 2 and 4, both carbons are in both cases carbons in the middle. So possibly 2 and 4 would be resonance structure. Let's just verify. Okay, make sure that if you want to check if they are resonance structures, they have to have the same number of number of valence electrons shown. Okay, and it's just a different way of distributing the valence electrons. So here you have an octet. You have an octet, and the carbon itself also has an octet. Here you have your sulfur has an octet, your oxygen has an octet, and your carbon also has an octet. So in fact, if you count the total number of electrons here, it's going to be this octet plus that octet. So that's 8 plus 8. That gives you 16 electrons. This is also 8 plus 8. That's also 16 electrons. So what's the difference between these two, structure 2 and 4? These have 2 double bonds on both sides of the carbon, whereas here you have a single bond and a triple bond. So 2 different ways of distributing the electrons. So these are resonance structures. Okay. Now let's take a look at this one over here. So these are resonance structures. How about these two? Could these be resonance structures? Well, you got sulfur in the middle for both. You have carbon and oxygen on the side, so possible. Let's just verify. Here you have an octet and an octet, but here you have only 6, and you only have 6 here. So this has only 12 electrons, whereas this top one has 16 electrons. So these don't even have the same number of electrons. You can't refer to these two as resonance structures, so they're not resonance structures. Okay, now let's take a look at isomeric structures. So, for isomers, the connection between the atoms must be different. So these two can't be isomers, and these two cannot be isomers. So let's take a look at this pair right here. Can these two be isomers? Well, let's see. You have both have sulfur, carbon, and oxygen. The carbon is in the middle in structure 2. Sulfur is in the middle of structure 1. Both have 16 electrons. You have octet here, octet here. This one is an octet on the right and an octet on the left. Same number of electrons. Okay. Different ways of connecting the atoms. So structure 1 and 2 would be isomeric structures. Now, structure 3 here doesn't have an isomer because structures 1, 2, and 4 have 16 electrons. This has only 12. Structure 3 only has 12 electrons. Okay. Now, can you consider these two isomers, 1 and 4? Yeah, they are also isomers. Okay. It's just the atoms are connected differently. The important thing to realize is structure 2 and 4, because they are resonance structures, they actually represent the same molecule. Okay? Basically what we're saying is it's the same molecule, it's just 2 different ways of distributing the electrons, and so one of these may be more significant than the other in terms of representing reality, but what we're saying is reality is probably not any one in particular, but it's sort of a hybrid of structure 2 and 4.